Waiting to buy a home? The Churchill Mortgage team says now is a great time to buy. Waiting could be a costly mistake because when rates drop, new home buyers will flood the market, driving up home prices. Go to churchillmortgage.com for your free analysis and see how home values can outpace rates to help you build wealth over time faster. This is a paid advertisement. NMLS ID 1591. NMLSconsumeraccess.org. Equal housing lender. 1749 Mallory Lane, Suite 100, Brentwood, Tennessee 37027.
Hey, Cricket customers, Max with ads is included with your Cricket $60 unlimited plan at no additional cost.
Nice!
Max is the streaming platform where you can watch Scoob, Meg 2 The Trench, The Nightmare on Elm Street collection, and so much more.
Remember me.
Just log in with your Cricket username and password to experience Max on all your favorite devices.
We've never seen this before.
Max, the one to watch for a good scream with Cricket. Phone plan streams in standard definition. Programming subject to change. Fees, terms, and restrictions apply. See cricketwireless.com for details.
This is SpaceTime, Series 26, Episode 20, for broadcast on the 15th of February 2023. Coming up on SpaceTime, a new ring system discovered in our solar system, a molten rock layer discovered just under the Earth's crust, and China unable to re-establish contact with their Mars rover. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a planetary ring system around the Pluto-sized dwarf planet Quaoar. Discovered in 2002, Quaoar is a 1,110-kilometre wide world orbiting the Sun in the Kuiper Belt, out in the darker reaches of the outer solar system. The Kuiper Belt is a ring of frozen worlds, comets and icy debris circling the Sun out beyond the orbit of Neptune. It orbits the Sun together with at least one known moon, the 80-kilometre wide Waywat, at an average distance of 43 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, roughly 150 million kilometres. The discovery was made using the European Space Agency's Cheops spacecraft and the 10.4-metre Gran Telescopio Canaris on La Palma. The rings are too small and faint to see directly, but were observed during an occultation. That's when the light of a background star was blocked by Quaoar as it passed in front. The event lasted less than a minute, but was unexpectedly preceded and followed by two dips in light, indicative of a ring system around Quaoar. Observing how light from an occulted star drops provides information to astronomers about the occulting object's size and shape, and it can reveal whether the intervening object has an atmosphere or not. In this case, the smaller drops before and after the main occultation betrayed the presence of material in a ring around Quaoar. Ring systems are relatively rare in our solar system. As well as the well-known rings around the giant planets Saturn, Jupiter, Uranus and Neptune, only two other minor planets possess rings, Chariklo and Haumea. Quaoar's rings are unique, orbiting much further away from the dwarf planet compared to, say, the rings around Saturn. And that's posing a bit of a challenge for ring formation theories. All of the previously known ring systems are able to survive because they orbit close to the parent body so that tidal forces prevent the ring material from accreting and forming moons. What makes the ring system around Quaoar so remarkable is that it lies at a distance of over 7 planetary radii. That's twice as far out as what was previously thought to be the maximum radius, according to the so-called Roche limit, which is the outer limit where a ring system's thought to be able to survive. The main rings around Saturn lie within just 3 planetary radii. Earlier results suggest that the frigid temperatures around Quaoar may well play a role in preventing the icy particles from sticking together, but more investigations will be needed. One of the study's authors, Vic Dillon from the University of Sheffield, says the discovery's forced a rethink on theories of ring formation. He says it was unexpected to discover the new ring system in our solar system, and it was doubly unexpected to find the rings so far out, challenging previous notions on how such rings form. Quaoar is one of 3,000 known small distant worlds referred to as trans-Neptunian objects, so called because they orbit the Sun beyond the orbit of Neptune. The largest of these worlds are Pluto and Aries. Quaoar ranks around number 7 on the size list. Usually studying these dwarf planets is difficult both because of their small size and also their extreme distance. Recently, the number of observed stellar occultations has increased. That's partly due to the contribution of data being made by ESA's star-mapping Gaia spacecraft. Gaia is mapping the nearest billion or so stars to the Earth. ESA wanted to see if the Cheops spacecraft could also be used for these sort of observations. The main concern was that while the satellite's trajectory could be slightly modified by using the drag of the upper parts of Earth's atmosphere, this only happens when space weather events cause the solar wind, the constant stream of charged particles emanating from the Sun, to puff up and expand the Earth's upper atmosphere. And that's unpredictable. Indeed, the first time the team attempted to observe an occultation with Cheops, this one involving Pluto, the prediction wasn't quite accurate enough and no occultation could be observed. Luckily, the alignment went far more favourably on the second attempt when they observed Quaoar. In doing so, they made the first ever detection of a stellar occultation by a trans-Neptunian object from space. And the Cheops data provided an amazing signal-to-noise ratio. That's because the spacecraft isn't looking through the Earth's thick lower atmosphere. And this clarity proved decisive in recognising Quaoar's ring system because it allowed the authors to eliminate the possibility that these drops in light were simply caused by the effects of Earth's atmosphere. This report from ESA TV.
CHAOPS stands for Characterizing Exoplanet Satellite, and it's a small mission in ESA's science program. It's very exciting because what we're doing is following up on known exoplanets. More than 4,000 have been discovered to date in the 25 years since the first exoplanet orbiting a Sun-like star was found, and CHAOPS provides us with an opportunity to do some first-step characterization. We'll be studying some of the smaller planets, so planets, so-called super-Earths, so Earth to Neptune-sized planets, and looking to understand better what they're made of and how they form and evolve. And this is one of the steps towards perhaps the ultimate question that we ask ourselves as a civilization, and that is, are we alone? It's been a really interesting project to work on, fast, unlike some of ESA's larger missions, which have much longer timescales. I've been involved from not quite the beginning, but from about 1.5 years since the mission started. And so what is really nice is I've been involved in the development, and I'll be working now on the operations. And that'll be very exciting, following up on some of the targets which have been shown to be very interesting by other missions, but CHAOPS will put the icing on the cake. The science program of CHAOPS is defined by the science team of CHAOPS, so from the consortium. 80% of the time goes to them, but 20% is open to the worldwide community at large. If you have a good proposal, you can apply for time, and if it's of high scientific merit and you make good use of the capabilities of CHAOPS, CHAOPS will give you time. Very exciting opportunity for scientists at large. What's my favourite exoplanet? That's an interesting question because you could say that the first exoplanet to be found, hot, puffy, gassy Jupiter-like planet, is a very interesting planet, but also the smaller planets, rocky, lava worlds. It's difficult. There's such a wide range of planets that have been discovered. All sorts of sizes, masses, temperatures, orbits, all very, very different from those in our solar system. It's a difficult choice. It's like opening a chocolate box and you asking me which is my favourite chocolate. I like all chocolate, milk chocolate, but choosing which one to go for first is a difficult one. So with CHAOPS, we use the technique of transit photometry, and that is to monitor the light from a star as the planet moves between the star and the observer. What we do is monitor the light as the planet moves across the disk of the star. So what the planet does as it moves across the disk is to obscure part of the light from the star. The bigger the planet, the more light it obscures. So the smaller the planet, the less of the light that we block, and so the more difficult it is actually to measure the transit depth because it's smaller. And that's actually the benefit of CHAOPS. We'll be looking at these smaller planets, and because we'll be following up, we'll be able to come back to the planets, the star and its planets, each time the transit occurs. We'll be able to observe all sorts of transits around the sky and come back at this critical period as the planet moves across the disk of the star. What we can also do is measure the so-called phase curve of a planet. And so what we're doing there is measuring the output of the light from the star as the planet moves the whole way around the orbit. So what we're doing there is measuring the reflected component of the light from the planet, as well as the dip caused by the obscuration of the star by the planet. And from this phase curve, we're able to find out quite a bit about the dynamics of the atmosphere.
And in that report from ESA TV, we heard from ESA CHEOPS project scientist Kate Isaac. This is Space Time. Still to come, a molten rock layer discovered just under the Earth's crust, and China unable to re-establish contact with their Mars rover. All that and more still to come on Space Time.
OTR drivers, keep your business rolling and your finances traveling toward a positive financial future. Make TaxesForTruckers.com your partner to handle the money side of things. Started by the daughter of a long-haul driver, TaxesForTruckers.com understands your business and can help you pay less taxes, keep your books, and track your finances, keeping you on the road towards your financial goals. And they're local in the Midwest, but available nationwide. Get started at TaxesForTruckers.com. That's taxes, the number 4, truckers.com.
Scientists have discovered a new layer of partly molten rock just under the Earth's crust. The discovery, reported in the journal Nature Geoscience, might help settle a long-standing debate about how the planet's tectonic plates move across the surface. Convection causes material from deep in the Earth's mantle to rise to the surface along mid-ocean ridges. This material then travels across the surface as it cools until it reaches a subduction zone, usually near a continental plate. At these zones, the now cooler material sinks back down into the mantle. In the past, scientists have detected what they thought were isolated patches of melt, which they figured were associated with this process. And interestingly, these melt patches were all at roughly the same depth. The new study has revealed for the first time the global extent of this layer and the part it plays in plate tectonics. The molten layer is located roughly 160 kilometers below the planet's surface, and it's part of the asthenosphere, which sits just under the Earth's tectonic plates in the upper mantle. The asthenosphere is important in plate tectonics because it forms a relatively soft boundary that lets tectonic plates move through the mantle. The reasons why it's soft, however, are not well understood. Scientists previously thought that molten rock might be a factor. But this study shows that melt, in fact, does not appear to be noticeably influencing the flow of mantle rocks. The study's lead author, John Lenoir from the University of Texas at Austin, says when scientists think about something melting, they intuitively think that it must play a major role in the material's viscosity. But these new findings show that even where the melt fractions are quite high, its effect on mantle flow is still very small. According to the research, which Hua began as a graduate student at Brown University, the convection of heat and rock in the mantle are the prevailing influence on the motion of the plates. Although the Earth's interior is largely solid, over long geologic timescales, rocks are somewhat malleable, and they flow like very slow-moving honey. Showing that this melt layer has no influence on plate tectonics means one less tricky variable for computer models of the Earth. Instead, it shows that these melt regions are more of a marker of what's going on, rather than an active contributor to anything. The idea to look for a new layer in Earth's interior came to Hua while studying seismic images of the mantle beneath Turkey during his doctorate research. Intrigued by signs of partial molten rock under the crust, he compiled similar images from other seismic stations until he had a virtual global map of the asthenosphere. What he and others had taken to be an anomaly was in fact commonplace around the world, appearing on seismic readings wherever the asthenosphere was hottest. The next surprise came when he compared his melt map with seismic measurements of tectonic movements and found no correlation, despite the molten layer encompassing almost half the Earth. Understanding the properties of the asthenosphere and the origins of why it's weak is fundamental to understanding plate tectonics. and through that, a better understanding of the planet upon which we live. This is SpaceTime. Still to come. China unable to re-establish contact with its Mars rover. And later in the science report, a new study shows that Bigfoot sightings across the United States tend to rise and fall in line with black bear populations. All that and more still to come on SpaceTime. China has lost contact with its Mars rover and has been unable to re-establish communications. The Zhurong rover has been exploring the Utopia Planitia region of the Martian Northern Hemisphere since landing on the Red Planet on May 15, 2021. Zhurong, which is named after a Chinese god of fire, was placed into hibernation mode over 6 months ago in order to deal with the cold Martian winters, where temperatures commonly drop to below minus 100 degrees Celsius. Compounding the problems, the area also experiences a severe regional dust storm, which mission managers fear may have prevented the rover's solar panels from getting any power. Zhurong was designed for a 3-month primary mission, but it remained operational for more than a year, travelling nearly 2 kilometres across the red planet's surface. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. The World Health Organization has declared that the COVID pandemic is not over yet, and it's still a major public health emergency of international concern. The body's advisory committee says the COVID-19 pandemic is probably at a transition point right now. They say long-term public health action is still critically needed. The organisation says while eliminating the virus from human and animal reservoirs is highly unlikely, mitigation of its devastating impact on morbidity and mortality is achievable and should continue to be a priority goal. Over 6.8 million people have now been killed by the COVID-19 coronavirus since it was first detected near China's Wuhan Institute of Virology around September 2019. The World Health Organization estimates the true death toll is likely to be around 16 million, with some 676 million confirmed cases globally. Scientists have created a new type of synthetic living cell in the laboratory. A report in the journal Advanced Science claims these cyborg cells share many characteristics of other living cells while lacking the ability to divide and grow. Cell engineering is currently based on either genetically modifying existing cells to give them new functions, or by building synthetic cells from scratch which can't replicate but have limited biological functions. But these new cyborg cells are based on a third approach, which adds artificial polymers to existing bacterial cells. Once inside the cell, the polymer is exposed to ultraviolet light, and that changes it into a hydrogel matrix by cross-linking, mimicking a natural extracellular matrix. The new cyborg cells preserve essential functions, including cellular metabolism, protein synthesis, compatibility with genetic circuits, allowing them to maintain normal biological functions, and to retain resistance to stresses like high pH and antibiotic exposure. Scientists believe their cyborg cells could one day improve treatments for diseases like cancer and even be used to clean up environmental pollution through targeted chemical processes. A new study has found that Bigfoot sightings tend to rise and fall in line with black bear populations. The findings, reported on the pre-press journal BioArchive, show that for every 900 black bears seen in an area, one Bigfoot sighting is likely to follow. The Bigfoot sightings are based on data from the Bigfoot Field Researchers Organization, the BFRO. The sightings were then compared to information on black bear density and spread, as well as human population densities. The study suggested the Bigfoot sightings are largely explained by misidentified black bears. The link, therefore, could provide scientists with a new way of assessing past black bear populations in a given area. Originally named Sasquatch by the First Nations people of the Pacific Northwest, the Bigfoot legend stretches back hundreds of years. They're said to be large, hairy, ape-like bipedal hominids standing around 3 metres tall, surviving in small groups or family units in remote wilderness. Despite thousands of footprint tracks, hair samples and blurry squatch blob photos, no credible scientific evidence proving the existence of Bigfoot has ever been found. Microsoft's just announced that it'll be incorporating its new AI-powered ChatGPT bot into its Bing homepage and update it to the Edge browser. With the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
So Microsoft was first with its announcement that it would have a special event in Redmond, and it ended up announcing that the OpenAI ChatGPT engine, a better version of the engine that's available at the OpenAI site, would be built into both Bing and Edge. And you can go to the Bing website, bing.com/new. You can join the waitlist. Microsoft is bribing people who join the waitlist to get quicker access to the new Bing if they change their search preferences for Microsoft's Bing, and also to download the Bing app. So I'm sure that over the next couple of weeks, the Bing website and the Bing app is going to see a big jump in traffic, bigger than any of its previous initiatives. And Google also, well, if anything's going to help Microsoft to get a leg up over Google in the search race, it's going to be AI. We've seen how powerful ChatGPT has been. Microsoft has invested $10 billion into ChatGPT, and so it's got first dibs on being able to integrate it into future versions of Windows, into the Office suite.
Well, it's just passed its law exams, and it almost passed its medical exams as well.
Yeah, well, with 100 million people having connected with ChatGPT, and with Google's own BARD, B-A-R-D, announcement, which would be coming in the next few weeks and being tested by internal trusted testers, not yet available for public use. Google is behind the 8 ball, and in fact, there was a piece of misinformation in Google's little graphical ad, its little animated GIF that was showing that one of the things you can tell a 9-year-old about the James Webb Space Telescope. And one of the things was that it said that the James Webb Space Telescope was the first telescope to take a picture of an exoplanet. And yet NASA said that this was done by a different telescope back in 2004. Because of that error, Google lost $100 billion US in market value. And I'm sure those values bounce around. But Google is at the moment behind. Now, Google did announce at its Search Maps and Beyond event in Paris that multi-search is now available on all phones with Google Lens. This is where you can take a picture of something and then, like it's a shirt, but it's a green shirt and you want it in a red color, for example. You can now mix and match words and pictures. And there's a bunch of other things. If you do a search for Google's blog post, if you just go to blog.google, you can find more information about all their recent blog posts there. And people were expecting to hear more about ChatGPT and Google's response to it. And in fact, we're really waiting to see what Google is going to do, when it's going to launch it. Since the ChatGPT AI-led revolution, everyone else is now trying to catch up. And the best Google has been able to do so far is convince one of its researchers that Google's Lambda AI chatbot was sentient, for which that guy got in big trouble. So
these new chatbots, are they in a single computer, or are they spread around dozens or thousands of computers around the world?
Well, I'm sure they're part of very large computers within data centers, spanning
large neural nets.
Yeah, I'm sure that there's no way there's just
like
running on one.
It's not like the HAL 2000.
Just what do you think you're doing, Dave?
Eventually, your phone will have all the power of the ChatGPT database inside of it. Things become centralized and decentralized all the time. And you will want to have access to all that information, like the Hitchhiker's Guide to the Galaxy, in your device when you're not connected. That's when it's going to be most useful. And I'm also very much looking...
Called it the Babelfish.
Well, the Babelfish was for translation, and sort of Google Translate already does that. One of the things I'm really looking forward to seeing is when a ChatGPT level bot, AI bot, is going to be available within Alexa, within Google Assistant, and within Siri. Because at the moment, you can ask it to do certain things or play certain songs or for certain information. And often it's not really sure what you're talking about. It's nowhere near as smart as what ChatGPT has proven itself to be. So I really hope that we see some massive advantages in our intelligent personal assistants this year, because, sci-fi has been promising it for a long time and big tech just hasn't been delivering.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.